Okay, so today we're going to be looking at hydrocarbons. So let's start off with what is a hydrocarbon? Let's have a look at the definition. So hydrocarbons are molecules that are made up of only carbon and hydrogen atoms. Hydrogen atoms, yeah. So if you were to see a molecule that contains carbon and hydrogen atoms, but then also contained oxygen or nitrogen, then it wouldn't be classed as a hydrocarbon because hydrocarbons contain only carbon and hydrogen atoms. So what else do we know about hydrocarbons? Well, there are actually two main types. So two main types. And these are called alkanes and alkenes. Now, there's one big difference between an alkane and an alkene. And when I draw both of them out in a second, I'm hoping you can spot that big difference. So let's draw our alkane. I'm going to be using a carbon chain that's made out of 3 carbons for each example, just so you can compare them a bit more easily. So let's draw our alkane first. So here we have our carbon chain that's made out of 3 carbons, and then you should know that a carbon atom can make 4 covalent bonds. So I'm going to fill the rest of these covalent bonds in with a hydrogen atom. And I'm using lines to represent these bonds. A single line equals a single bond. So here we have our alkane. Alkane. Okay. Now let's draw our alkene and see if we can spot anything different. Again, I'm going to be drawing our 3 carbon chain. And we've got our 4 covalent bonds for each of the carbon atom. So I'm going to fill these in with hydrogen atoms. And then I'm going to label this as an alkene. Alkene. There we go. So hopefully you should have noticed that the alkene has a carbon-carbon double bond, whereas the alkane has a carbon-carbon single bond. Now this is the difference between an alkane and an alkene. Alkenes contain 1 or more carbon-carbon double bonds, and alkenes contain just carbon-carbon single bonds. So if you were to look at the structure of a hydrocarbon and you were asked to identify if it's an alkane or an alkene, look for the double bond. If there is 1 or more present, it's an alkene. If there are no double bonds, all of them are carbon-carbon single bonds, it's an alkane. Okay, so now let's move on to the general formula of an alkane and an alkene. So let's just make some space here. Let's use orange. Okay, so the general formula of a molecule is an algebraic way of showing us how many carbons and how many hydrogens a molecule has. So let me write down the general formula for an alkane first, and I'll use that to explain what I mean. So the general formula for an alkane is CN, where N can be any number between 1 and infinity to represent the number of carbons in our chain. H, 2N plus 2, where N is of course the same number as the N for the carbon. So this helps us predict how many carbons and hydrogens a very long chain alkane would have. If in the exam you're asked to identify how many hydrogens an alkane with 50 carbons has, it would take a very long time and would be wasting your time trying to draw out the 50 carbons and then attaching the hydrogens and then counting. That would take a long time. So we can just use this formula to help us figure that out. So, okay, let's use the 50 example. So how many hydrogens does an alkane have that has a carbon chain of 50? So our N would be 50 because we have C50, and then our H2N plus 2. So 2N would be 50 times 2, which is 100, and then plus 2 would be 102. So that would be C50H102. So that's a very long alkane. Let's look at the example I've drawn here and see if it fits. So we've got 3 carbons, 1, 2, 3, so that would be C3, so N would equal 3, and H2N plus 2, so we do 2 times 3, which is 6, plus 2, which is 8. So it'd be C3H8. Now let's look at our diagram and see if we have 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So now let's move on to our alkene. Now the general formula obviously for an alkene is going to be different because we have our carbon-carbon double bond, which reduces the number of hydrogens we can have. So let's write out the general formula for an alkene. So the formula is CnH2n. So slightly more simple than the alkane. So whatever number of carbons you have, if you double that, you'll get the number of hydrogens. So let's see if that works with our diagram. So we have 1, 2, 3 carbons. So our N equals 3, so C3, H2N. So 2 times 3 is 6. So we should have 2 times 2, which is 6 hydrogens. Do we have 6 hydrogens? Let's count. 1, 2, 3, 4, 5, and 6. So there we have it. I've given you an introduction to hydrocarbons. I've given you an explanation of the 2 main types and also their general formula. Thank you.